gas for bigger changes to the state. So like deploying the contract.
More like computationally expensive, like time it takes to.
Yeah. So if you execute an instruction which takes a lot of CPUs, like a lot of instructions, that'll incur a bigger gas fee than something like that's like one instruction. Yeah. In terms of how long it takes for the client to respond to my request, there's a lot of ways that the clients can be implemented, which will reduce the latency. For example, like getting the latest block. It doesn't have to go through all the blocks to find the latest block. It just keeps track of the latest one it's seen, like in a different counter. So that it doesn't have to scan through a million blocks to find what's the latest one. Yeah. So usually, so the clients store these things in something called the Perpetual tree. So it has a Perpetual Merkle tree, sorry, and it has a lot of efficiencies for lookups. So even if I go back very far, you can just look up a hash of the block, find the data, and give it back to me. Yeah.
To expand on the answers to your question a little bit more as well, like you might get different answers from different nodes because they're all like constantly like syncing with each other and things like that. So they'll just give you like what they think is the truth, which might not be the same as like another node that's connected to the network.
Like every client would be connected to, let's say 50 nodes. It's like if they have conflicting answers, let's say, they take like the majority. Like I know it's async, so they'll come at like, do they just take the first one and rely on it?
Yeah. Yeah, pretty much. Like, so a node in the network will like, I think it's like one of the parameters when you run the node software is like how many peers do you want to connect to, just generally, and that'll kind of like determine like how many things it gets consensus from around it, so to speak.
And over time, they'll converge. So if like at one point in time, there's like 3 different like blockchain, like chain states, over time they'll converge, and then generally like a lot of apps will sort of set like a minimum number of like blocks. That's like the length before you start accepting the block. So it has to have been like accepted 10 blocks ago before they'll start accepting that sort of thing.
Yeah, it's also possible that the nodes, when they answer a query, they'll know that if they have, like as Ben said before, it'll wait for a certain number of blocks to have passed before giving you the next thing. So it'll be a bit behind just to make sure that it's reached consensus on like that latest block, but potentially for answering queries. But it depends on the configuration.
And if they don't converge, then that's like when you have a fork. If you have some miners who are adamant on maintaining one block state and some who don't, and they never like agree to like come back to some point and go from there, then you end up with 2 different chains, sort of thing.
Yes. So that's the basic thing for interacting with getting block information. So another one is if you want to interact with a smart contract directly. So here, what I do, I'm just getting information at a block for a particular smart contract for a particular address. So in this case, I'm getting the balance of a token called USDC for some random address I found on Etherscan. So to say what that is, so Etherscan is so Etherscan is an Arbix scan. All these scan websites, they keep track of information about the chain. You can query them for information. So in this case, this is the USDC token. It's a smart contract. It's of the ERC20 standard. This is its address, and it has a set of methods which you can call on that contract. So you can see here, I can get the balance of a particular account at a particular state of the chain. And you can call all these functions and get information back. So for example, if I wanted to get the number of decimals for the contract, so it's 6. So if I get a value back, I know I have to divide it by 10 to the power 6 to get the actual quantity of the token. So that's to prevent rounding errors. So they store the full value and then give you a decimal number to divide by. So in this case, what I've done is I know I want to call the balance of function on this smart contract, and what I did before is I can just go to the current transfers I've seen, and just pull a random address here. So if I just copy that address in, go to here. So if I change the account address to be that one, and I want to call it on this smart contract, and this is the method signature. So the way in which you call smart contracts, you have to specify what the function you're calling, and how that works is you have a canonical form of a function definition, which is the name of the function and then a comma-separated list of the types of the parameters. Canonical form. So take away parameter names and spaces, then you get the canonical form of the function definition you need to use for the method signature. So that's the first step. You have to find, you have to get the name of the function you want to call, or the signature. You then get the catch-ack 256 hash of that string, and take the first 8 bytes of that string, which that produces the function hash of the contract. And then after that, you put the encoded form of all the parameters for that contract. So in this case, it's a function. This is the signature. I hash it. I pull out the first 8 bytes, including the 0x at the start. This is all in hex, by the way. And then it has one argument, and the way in which this argument is, it's an address, and addresses are encoded in 64-byte chunks. So I then take the account address and just pad it with zeros to be 64 bytes long. So when I make a transaction, a query with a call data, the data there is just function hash and the arguments concatenated at the end. You can see here what I do. I get the latest block number, just so I know at which point in the chain I want to ask this question. In this case, I want to ask the question at the latest block, just to see what the latest thing is. The parameters I pass is the encoded for the function and its arguments, as well as the address I want to ask. So the contract I want to query. So in this case, the token contract we saw before, the ERC20 contract with that function. That's what I do. So I've encoded the parameters. I call the parameters. I get the response back, and that response is in bytes. It's the value of the balance of that address in bytes. I convert those bytes to their hexadecimal representation, and then convert the hexadecimals to an integer. Make sense? I haven't lost anyone.
Why are you hashing like a function that you're using?
Right. So the hashing is there in order for you to provide an easy way and also unique way of identifying a function you want to call on a contract. So if you have two functions with a conflict, it'll use the first one it sees. But this is just an efficient way of specifying what you want to call on a contract, and also have little to no conflict because it is a cryptographic hash.
It identifies the function. ID number for your function.
Exactly.
So right one,
yeah, so it's like, I'm calling this contract, here's a function hash, and it knows which function to call.
And you can concatenate that with the arguments to make sure it's like that's the simple one.
Yes, so it's you can concatenate the arguments on it, so you have a way of compactly and correctly specifying what you want to call that function with.
The function hash is also determined by which arguments it accepts as well.
Yeah.
So if there's two functions with like the same name but different arguments, they'll produce different function hashes.
And the benefit of hashing it is like, it means that the function signature is always like the same length, no matter how long like your function name is or whatever. And then when you take the first 8 bytes, it means like all function selectors, which is what that's called, they're all the same length because it's like you just hash it and take the first 8 bytes or whatever.
Yes. So you identify the function, provide the arguments, and then send that to the contract, and the contract responds. And in this case, I've decoded it. I know it is an integer response value because it will be an integer. And then just decoded it here and then print out the results. So I've changed that address now. So let's have a look here. If I run that, I save the file. So that contract, or that address, has a balance of that big number. And remember how I said before decimals? So it has a decimal value of 6. So I divide this by, I move this by 6. So 1, 2, 3, 4, 5, 6. So it has 11,492 USDC in that, or that address has 11,000 USDC at the current block, which I queried. So at this block, it had that much. And to verify this, I can go back to Etherscan. I can copy this address, go to the contract, ask that question, and I get the same answer back. So yeah, you can also interact directly with contracts via Etherscan as well if you provide the parameters. But this is just like going into the underbelly of what actually is happening in the back end. Okay, so back to the presentation. Yes, I'll now hand over to Chris.
Thank you. Yeah, I will now go over briefly what the EVM is and what that means, and kind of shed a bit more light on like how that contract is like calculating that number and then giving it back to the user. So the EVM itself is essentially like the execution environment for these smart contracts and for the chain state itself. It is it's kind of like all of the nodes on the network have to be running this software that all agree that given some transaction, which is like the instructions on how to do a state change, that when they process that, the outputs are always going to be the same, so they can stay in sync and not fork when the transaction comes in. The EVM itself is a stack-based execution environment, meaning that the way that like functions and state transitions are formatted is they're just like opcodes, so like essentially low-level functions, and then the arguments all in the right order. And then when the nodes are like executing this contract code in the EVM, they're basically like pulling instructions off the stack, and then that instruction might tell them to like do something with the next two things off the stack. So yeah, if you're familiar with a stack-based execution environment, this is one of those. So the nodes themselves are, you could consider them as like implementations of the EVM. The actual node software itself are called client implementations. So they're like a few different major ones that are running on the network, and they obviously all have like dev teams that are constantly supporting them and making sure that they don't have like breaking changes that will cause forks with other client implementations. And then the nodes themselves are defined as like the actual machines that are running that client software. And the nodes themselves will usually expose like a REST API for things like reading contract state, or like a standard way to tell them that you're trying to send a transaction. Yeah, and as long as they produce the same state output for the same transaction or state change inputs, then that means that those two client implementations are compatible. So the actual low-level spec is defined in the Ethereum yellow paper, which is essentially like a document that outlines things like what opcodes need to be supported, so like what functions like pop, push, add, multiply, all those kind of like low-level things, and also like how much gas is assigned to each of those. So when we're talking about functions that do big state changes, they cost more gas. The reason for that is because certain opcodes in the EVM cost more gas to do. So like things like multiplying and dividing cost more gas than like addition or something like that. So there's a whole like niche of like optimizing your contracts to be like as gas efficient as possible. And usually you just let like entities do that are really good at that, and then they'll provide you with like optimized contracts that you can use in like your stuff. Yeah, so that's essentially what the EVM is. The EVM is just an implementation of some software that can read that bytecode, knows how to execute it, and then can tell the person what the state of the chain is after it's done that. So now, essentially, to get from the smart contract code, like for instance, what you can see here is basically like the hello world of a Solidity contract. And so this goes through a compiler, which is like the Solidity compiler, similar to any like C compiler or anything that you might already be familiar with. And this is kind of like the output in opcode format that you would expect for that. So the EVM software, or the part of the execution environment part of the client software, is just the stuff that reads this, applies like your function selector and the arguments for your function, and then executes it and gives some output. So smart contracts must be compiled to EVM bytecode, and what this means is that smart contracts don't necessarily need to be written in any particular language. They can be written in something that looks very close to bytecode, or they can be written in something that looks more like a JavaScript or Python or something like that. So Solidity is probably closest to JavaScript, I'd say. So yeah, and it's also like the leading language that most people use for their contracts, so at least for EVM chains. So I think we touched on this previously before, but deploying a smart contract itself is essentially saying, I want to add a new custom state transition function to this big existing state machine that everybody is maintaining. So the way that's done is you're essentially deploying this bytecode that we've seen here. In reality, it would be like hex or in binary, and you'd be telling the nodes that, hey, I want to put this code at this particular address on the state machine, and then whoever wants to call it can call it and interact with it. And yeah, if you want to deploy a really big contract, then you have to pay a higher gas fee because it's changing the state more. So in general, a transaction will be, I think we saw, I won't go all the way back, but transaction will generally define who it's coming from, where it's going to, but a smart contract is going to like the state machine itself, so to speak. So what you're really doing is you're just saying to the nodes, hey, put this data into the null address, and the software implementation itself recognizes that as a contract deployment. So it will then go and deploy functionality at that address. Yep.
Are these contracts like stateless in the sense that they only dictate like sort of state transitions of like the Ethereum blockchain itself, but then they don't store any of the state that they sort of manipulate?
So they do actually store both. So that USDC contract that we were talking about just before, so that stores things like what the balance of each address is, or one of the like main functionalities is to like approve another address to spend yours. So it'll keep track of things like how much of you approve another address to spend on your behalf and things like that. So yeah, a lot of them do. It doesn't necessarily have to have state, but yeah, it'll pretty much always at least have a state transition. Yeah, but in most cases it'll have both state and logic to do state transitions.
Another way to think about it is like the smart contract is like a set of instructions that's stored at a particular address, but also has control over like that particular address. So like if you transfer like ETH or some crypto like token to that address, and it's able to somehow like manipulate its own address, it will like be able to do so.
Okay. What if you kept like adding to like an array infinitely by mistake, like in that in state that's stored at that address?
Yeah.
Like what's going to happen?
So either what will happen is, since adding to that array is an opcode that costs gas, either you'll run out of gas, or you'll pay a lot of gas, or it'll revert because you can. There's essentially like a limit, a stack that once you go too deep, it reverts after that.
What if you do it over many transactions?
If you do it over many transactions, then you're all good as long as you're willing to pay the gas to store it and do the state transitions. Yeah. But usually what you'll do is like when you want to submit a transaction, you'll set an upper bound of the gas that you're willing to spend so that you don't accidentally do things like that. Yeah, that's kind of the overview of the EVM and how contract code living on the actual state machine works and how it's like, run by the nodes. So if there are any questions, then feel free.
We're not done yet, by the way.
Yeah. Yeah, I think we're going to just take a quick break then if no one has any questions about that. So, yeah. So give it a few minutes.
I actually have one question.
Oh yeah, go on.
If you know what, like, I mean, you would know what Bitcoin Core is. Like, what's the one-to-one mapping to like Ethereum of like what Bitcoin Core is?
So that would probably be like the most common client implementation, which would be Geth, which is an Ethereum client implemented in, yeah, it's implemented in Go. It's like Go Ethereum essentially. But yeah, because Bitcoin Core is just like the most commonly used one essentially.
So like Geth would be like dealing with like low level like line manipulations for the virtual machine.
Yeah, but it doesn't have to be Geth. Geth is just one of the client implementations. There's ones written in like Java and C# and all those, but yeah, Geth is the most popular by far.
Like a common one we also use is called Aragon, and it's written in Rust. There's quite a few.
Client diversity is like a big issue that there's like a big community push for, because Geth is definitely like the monopoly, but it poses a like risk to the decentralization aspect of the network security.
Well, then something like Bitcoin Core would also sort of ostensibly have like a risk of centralization, right?
Yeah, I think it's like more of a bigger risk in Ethereum because it is more complex of a blockchain, whereas Bitcoin changes far less frequently. So like that sort of risk isn't like so much an issue because it's much more battle tested. But it's definitely like I mean, I don't really know too much about like the Bitcoin sort of like ecosystem in that aspect. But I assume it's probably at least like somewhat of an issue.
Yeah, I think it's like something like high 90s is Bitcoin, like high 90% of the network is Bitcoin Core or something.
Yeah.
Yes.
So do you guys like trade coins or like try and optimize stuff or make?
At Mycelium?
Yeah. What's like the main goal of Mycelium?
So the main goal of Mycelium is to build, I guess, like products, like both developer-facing and user-facing.
Yep.
So developer-facing in the form of like the node infrastructure and like the data services and things like that, but then also user-facing in terms of like trading platforms, like exchanges and things like that. So yeah.
What's your like flagship product?
Flagship product is a thing called Perpetual Tools, which is like a derivative product that lets you like kind of get pseudo leveraged exposure to price feeds. So like the Bitcoin price feed or the Ethereum price feed or like the oil price feed or things like that. And essentially it's like if you're familiar with like leverage trading, it essentially is like you can have a leveraged account, but when there's no liquidation involved, it's like you always have the token you've gotten, but it's just like the value that can be redeemed for goes up and down over time. And once it goes to zero, you never lose those tokens, but it can go back up. So you never like fully lose your margin.
So basically, like the product is you buy a token which tracks the price of some underlying asset in like a certain fashion that usually represents some sort of leverage, rather than. It's not so much. I guess it's no. I mean, it's definitely not pegged, but it tracks it based on a certain value transfer function. So like the inherent like amount of collateral that backs the token changes over time based on a certain like leverage function, sort of thing.
So let's say you wanted like via Perpetual Tools to go like 3x leverage on Bitcoin. You put your money in, you get this token, and then immediately that token is redeemable for the same amount of money that you put in. but then as Bitcoin's price changes, that amount of money that you're able to redeem it for changes like in accordance with Bitcoin's price. So like for a 3x, if Bitcoin goes up 10%, then the amount of money you can get back in exchange for your token goes up.
I think it operates in a fairly similar way to like leveraged ETFs in like the traditional finance sort of market, if you're familiar with those at all.
So is the price like set by when you guys wrote, like take stock of like sort of all the inputs on the network and then sort of spits out like an X?
So it reads from an oracle. If you know about Chainlink, it reads from like a Chainlink oracle, although it can theoretically read from any like price oracle. And based on the change in price over a certain period of time, it transfers the collateral that backs either the long side or the short side. So if the price goes down, it'll reduce the amount of collateral that backs the long tokens and put it into the side that backs the short tokens based on a certain like function. So if it's like a 3x leveraged token, it'll like roughly match like a 3x, like whatever the price change was, as a percentage that backs each side's.
Like collateral, you mean the liquidity that people have provided?
Yeah.
Okay.
Yeah, the actual like tokens that they've deposited in to redeem these leverage tokens. If that makes sense.
I've got a new question.
Mm-hmm.
Say you want to transfer from one account to another, and you want to save money in gas fees. So you provide the lowest gas fees possible. But so it's going to take days, right? But during those days, the price of Ethereum just fell. So when you're trying to save money, when you're trying to save money by saving gas fees, you kind of lose money with the price fluctuations.
Mm.
So how do you like protect your savings from that? How do you make money?
So this is an interesting question, but a very interesting answer. So the one way is to track the trend. So it's it becomes more like an optimization problem because you're trying to optimize how much you save, but like how much do you go for having higher gas fees but also accounting for a drop. So you'll pay a higher gas fee, but get higher returns from the drop. So you sort of have to try to balance those two out, and that's a non-trivial thing to do in general. But usually you have some predictive model on the platform to try and do that. Or yes, it becomes an optimization problem.
Yep.
Sorry.
Yeah, you get best.
I was just going to say, would you just have like some sort of timeout on that so that you'd say, I like it at this price, but if it gets a bit too sketchy, if it hasn't cleared in so many blocks or whatever, just forget about it.
So it depends. Are you talking about like buying Ethereum at a certain
Or just
like
to
US
follow
dollar
on from that
price?
same point there, that you want to do a transaction, you're expecting it within certain bounds.
Yeah.
Can you say, well as like the max gas price, can you say I want this to go through in a sensible time frame?
Mhm.
If it hasn't gone through in 2 days, just don't worry about it type thing. You know, you might
Yeah.
so you can sort of test what you can get away with, and then you can say, well, it's taking too long, maybe I'll bump up, I'm willing to pay, maybe we'll just increment it to
Yeah.
find a sort of sweet spot.
Yeah. So there's no way to specify like an expiry for that, but the client implementations themselves, depending on the implementation, I believe they drop them after a certain period of time anyway, so they're not just all like sitting there pending. But what you've explained where you can bump up the fee, Matthias touched on one of the things in the transaction is a nonce. So what you can do is like submit the same transaction with the same nonce. Like the nonce is kind of like the identifier for it's like for that particular transaction, like so to speak. So you can submit like the same transaction with the same nonce with a higher gas price, and then they'll just forget about the other one because they'll be like, okay, this is the actual canonical one for this nonce. Yeah.
Yeah, so you can also do that to cancel a transaction where you reuse the same nonce and put a higher gas price, but just have a null transaction that doesn't do anything, and the miners are like going to see that with a higher gas price and do that, and then the one with the lower gas price, because another transaction with the same nonce by your address has already been done, it'll like drop that one.
Hang on, let's go. You've been sharp.
Have you guys thought of, like, are you trying to compete with neobanks with things like payday loans and stuff like that?
We are expanding our product into more like retail focused. We're not going directly for that specifically, but we're like, yeah, one of our focus at the moment is expanding into more like a retail friendly experience and things like that.
Rather than just
Crypto.com sort of thing.
Sorry?
I think it was Crypto.com there, like debit card thing, something like
Yeah.
that.
No comment.
No comment. Okay.
It's also worth noting that we're not a centralized exchange either, or at least like, yeah, we're definitely like as it stands today, like our products like all sort of operate in a relatively decentralized fashion.
I had a question about your answer to like sort of a null transaction. Does that like cost gas if you're doing null? Is it like changing state, I guess? Or?
I'm actually not sure. Do you know?
I would say it will cost you. It costs more gas than you're originally going to, at least more gas than you're originally going to pay to cancel a transaction. But in terms of like actually the gas cost for like the opcodes involved, I believe that like because what you would do is you'd set like the base fee higher, so the miner doesn't actually have to do anything. They just have to like accept it.
So it might be less gas price just because like there's less opcodes involved in a null
Yeah.
transaction.
Yeah. Yeah. Okay. Well. Yeah. Was there any plan for intermission, or are we just happy to power on?
I think pizza.
I think they're bringing pizza at the moment.
Okay.
It's in the process.
Yeah,
I'll have a quick.
I didn't want to be so blatant, but yeah.
Do you know how far away they are?
Yeah, I'll have a chat.
Yeah, okay.
How does something started in like Web3 stuff? Like, do you read the white paper, docs, and just follow the tutorials?
The white paper can be a bit of a daunting task to take on like, if you're new to the space. I think like if you're just looking to get purely into smart contract development, it definitely makes sense to just I've kind of like when I first started, which was like 2 years ago, the tutorials that existed online were very like limited and poor quality. But I think like now there's quite a lot of good tutorials that you can sort of like just follow to teach yourself, and then like try to just start like experimenting with your own sort of smart contracts, I guess. But then there's always the other sort of side of it, which is like the off-chain aspect. Like you generally like will always like eventually have to write some sort of like bot or something that interacts with smart contracts. But yeah, I can't really give you any specific like tutorials to get into. But
Free Code Camp has an 11-hour Solidity tutorial.
I would also recommend one called Crypto Zombies, which was how I got started, which is pretty good.
I can assure you better ones than that now though.
Maybe, maybe, probably.
I think I've got the unique case. I just jumped into it with work, so I was forced into space.
I think an underrated like activity though is like learning Ethereum Solidity code. Ethereum assembly sort of programming. Like as in programming directly with the opcodes. So there's a language called Huff, Huff, which is essentially like an assembly language, which like it's not necessarily like a good idea to write sort of very complex smart contracts with that because the complexity is sort of like multiplied. But it definitely helps a lot in like learning Ethereum and like how it works sort of thing.
Like if you want to have like some good reading, is Ethereum.org has a lot of information on the insides of EVM as well as how a lot of things work as well. So it's good for general background knowledge. It also has links to the yellow paper, so you can read them from there.
Would there be like an equivalent, like say if you're doing network programming, you do like GCP or something, if you like look at the RFCs or have like all like what each thing does, is there like a similar thing to the opcode sort of thing?
So there is an opcode reference guide, yeah.
There's quite a few.
Yeah. Yeah, and they'll tell you like what the actual byte representation would be, how much gas it costs to do, and then kind of like the definition of it, like what it does, like pull the next two off the stack and or something like that, and put it back on.
Basically all opcodes are just stack input, stack output.
Yeah.
Essentially.
And also, like, some compilers also come with the ability to give you estimates of how much gas it will cost to run each function in the thing you compiled, which is really useful.
For the leverage trading service, is that a Mycelium service you're saying?
Yeah.
Yeah.
But it's like the protocol itself is like a smart contract or a set of smart contracts that are just deployed onto the chain.
Okay, so that would be for the use of buying cryptocurrency with leverage then. Okay.
Yeah,
So you would.
in a tokenized form as well, which is another distinction.
Okay. Who would be the end customer if you're buying call options? Who would be buying the put options on the other side?
In this case, it's like there doesn't necessarily have to be a counterparty because the token, like the smart contract, is written such that you will always be able to like redeem your token for a certain amount of like underlying collateral based on like the logic that the smart contract executes.
Okay. So when you mean collateral, is that like
just actual like real tokens, like
Okay.
not these like leverage tokens, but like actual like US dollar stablecoin tokens, for example, that people have like deposited in.
Right.
So say if I deposit like $100 into the pool and like then like the price drops such that the amount of collateral in the long side decreases by 10%, theoretically I would then like end up with like $90 worth of tokens.
Right. Okay. So there's two pools then.
Yeah. So
Right.
there's like always the long and always the short side.
Right. Okay. And
Yeah.
basically, exchange rate sort of between them is gonna give you your times the leverage factor. Will
Yeah,
give you
yeah.
your take. Okay.
Yeah.
Interesting.
So that's what we call the value transfer function. So it determines how much of this collateral gets transferred from the losing side into the winning side.
Right.
For every like update interval.
So you're just banking that the transactions will flow equally both ways over time with a large
Yeah.
holding pool.
Yeah, so there's an interesting mechanic in this product where when there's a side that's under collateralized, so it's got less collateral than the other side, it's got a larger effective
The leverage
leverage
gets
on
higher.
the gains.
Yeah.
Because like if one's got double the amount that the other one has, 10% of this one going into the other one is going to be much more than 10% gain effectively. If that makes sense.
Okay. And is that across like any? Is this same pool for like any sort of cryptocurrency? Or like, could you use the same? Is it the same buy sell pressure pool for Ethereum versus for like Bitcoin?
So they've got separate. Like each market has a separate.
Each
pool
market,
of
yeah.
both.
Because otherwise, you could have if there was a downtrend in time in Bitcoin, then the long side becomes very valuable, and then you could use another market that's on the uptrend, and then that would just
Exactly. That's what we call skew farming. So when
Yeah.
there's a skew in the pools,
Yeah.
there's an incentive to enter the under collateralized. And if
Yeah.
you can do this in a way where you hedge your exposure to whatever you're like going into,
Yeah.
you can like farm a reasonable amount
Yeah.
of yield,
Interesting.
depending on how much skew there is.
It's a cool product.
Yeah, it's definitely like got some interesting use cases, and there's like some people that are making like I don't think like at the moment there's like too much money to be made, but there are some people who are like farming the skew like pretty consistently.
And there'd be a lot of liquidity added from all that trading activity as well.
Yeah,
Yeah.
yeah, and the skew farming I guess adds
Yeah.
as well.
Has anyone dabbled in this stuff before, previously?
In derivatives trading?
Or Web3 stuff?
Or derivatives
Or
trading.
Yeah, or derivatives.
I did 4 hours that tutorial, I said.
Oh, cool.
No, stop. Yeah.
Fair enough.
40% of the way there.
Yeah.
To being a god tier dev.
What were they teaching in their tutorial? What were they teaching in their tutorial?
Solidity.
Yeah.
Solidity. For any particular like application?
No, it's a bunch of like toy applications as well.
Okay.
It's definitely good to read some of the like more notable like fundamental protocols that exist as well, like as a learning exercise. Like Uniswap, for example, is like a decentralized exchange, like an automated market maker exchange. And then there's like the lending and borrowing protocols, like Aave and so on, that are definitely like staples in the sort of like blockchain ecosystem.
Sure. I just wanted to ask you guys about sort of what you think about like DAOs, because like I don't know, I have a mate who lost like $5,000 off just like, what do you think about like the general idea of like a DAO?
Well, that's just one DAO. DAO just stands for like a decentralized autonomous organization. So you can have DAOs that promise like 10,000% like APY on like your investments, or you can have DAOs that build, for example, like Uniswap or something. So there's definitely a spectrum of like legitimacy in terms of like DAOs. Like you can have like legit DAOs and you can have bad DAOs. And you can also have DAOs with different degrees of decentralization. So you can have DAOs that are basically just run by like one council, and they have like some sort of decentralized aspects, or you can have DAOs that there's like full like flat hierarchy. So I guess like yeah, it just really depends.
All right. Do you want to do one last?
What would you do to get into sort of security for crypto?
Yeah, like there's definitely like first of all you need to learn like basic smart contract development, but then there's actually quite good like public like community like security auditing projects that exist. So if you go to Code Arena, but Code 4 Arena, like the A in Arena is the 4, .com, they have like audits where like people will put up their DeFi projects and anyone can come in and like audit it and submit security vulnerabilities. And like that's a really good way to just practice that sort of thing. But then there's also like CTFs, which we'll be talking about, which are another way of practicing like when you know there's like a security vulnerability there. So I guess like just practicing those sorts of things. And there's also like boot camps that exist as well. But yeah, just like there's heaps of stuff that you can get into with that sort of thing.
And it's very similar to your typical security vulnerability communities, like similar sort of thing. People get together, they try to break stuff, and then also kind of come together, see if they can make things better, sort of thing. Yeah, so pretty much just same thing, different flavor.
Yeah.
Yeah.
All right. I think we have pizza outside as well. So anyone who's keen for pizza, it's pizza time. To round off the intermission.
Oh yeah. I was all fired up and I was like, here we go. This is going to be the best LED flash I've ever seen. And then
I need to get them somewhere soon, so.
oh, that's why it's like a mouse. Big ass purple cube.
Damn. That's amazing. Well. Well. Good me luck. Yeah. I'll wait for that too.
Confusion.
The classic strategy of wake up late, breakfast is lunch.
guess the number challenge. This is just defining like a state variable, and then you have this here. This is the constructor. So this is just like how you like what function is called when you create a contract. And this function here is complete. It's just a public function that returns a boolean. So in this case here, it returns whether its address has a balance of 0, so 0 ETH. So basically the way that you solve this challenge is to get isComplete to return true, and to do that, the balance has to equal 0 of this smart contract. So, and then this here, this function is called guess, and all it does is it takes in a parameter that's an unsigned integer of 8 bits. It requires you to send 1 ETH to it. That's just to make it like so that you actually have to like be guessing correctly. Otherwise, you're just going to be losing all your ETH. And then if n equals the answer, it transfers it transfers 2 ETH to whoever called it, the message.sender. So I guess like, yeah, that's basically like what the smart contract does. Does anyone have any questions about this? Because obviously I'm just sort of like running through it pretty quickly. Does anyone have any questions about like how this smart contract works?
It's already one.
Yeah. So I guess in the constructor up here, it requires, that's just like an assertion, that message.value equals 1 ether. So what that means is whoever's deployed this smart contract has deployed it and sent it 1 ETH. So it's actually sent it some like ETH into this smart contract. So on deployment, this smart contract is the owner of 1 ETH, basically. Do you reckon that's good? Yeah. So if we also like understand what's happening here, at least to some like degree, does anyone have any ideas, just starting off here, how we would get this contract to start returning true for isComplete? I'll, I guess, like give you some time to think about it. The answer might be more obvious than you're sort of like guessing or trying to figure out. Or if you have any questions as well, feel free to ask. But I'll just give you some time. Yeah, I can show that. Yeah. Yeah, definitely. No, we can at least one. Yeah, but we can just show it like how to do it without actually doing it. This is what you want to do if you. So I'll just like remind you this state variable here, answer, is like sort of defined at compile time to be equal to 42. So like typically you can like change these unless they're immutable or constant. But in this case, like it's just like a normal variable. Like its mutability isn't really relevant here, but yeah, like that's just sort of like a value that's stored inside this contract, so it always has access to this value.
You just call a guess function with n equals 42 like a bunch of times until it, and like on each iteration keep calling isComplete until it's 0.
Keep calling isComplete till it's 0?
No, keep calling guess till it's 0.
How many times would you need to do that?
Like 21. Because it's half of 42, I don't know.
So it's definitely very close. But I'll sort of like, I guess I'll like just iterate on like what this does here. So when the contract gets deployed, the constructor is called, this is the constructor, and it asserts that it's been deployed with 1 ETH. So it is in ownership of 1 ETH. And then what guess does is if it first asserts that this function is being called with 1 ETH, so it like also deposits another ETH into this contract. And then if this if condition is satisfied, it then transfers the message sender 2 ETH. So it starts off with 1 ETH, then it gets 2 ETH, and then if this function is like, if this branch is entered, it transfers out to ETH, if that makes sense. So based on that, like, I guess like, I'm trying to think of like a good like prompting question, but like, so like after you call it after you call this function successfully one time, how much balance will this contract have? If it starts off with 1 and then gets another 1 after you enter this contract, and then it transfers out to, if this is satisfied.
Of 0.
Yeah, exactly. So yeah, exactly. So you just call it once. So like, yeah, the answer equals 42 is defined up here, and then if n equals answer, which is 42, it enters this branch. So like, yeah, that's like a relatively sort of like simple one. Definitely like, don't need to overcomplicate that one. But yeah, does anyone have any?
Why does the value increment if you just say message.value equals 1? Like, is that setting is calling that function just a transaction basically?
Yeah. Yeah, so any transaction always has associated with it a value field. So if I make a call on a smart contract function to do like XYZ logic, but I also make value equal to like 1 ETH, then it will, like along with calling that function, it will also send the target of that transaction, the smart contract, it will send it whatever I put in value as well. So I guess like, yeah, that's another thing that's
from the address that called the function.
From the address that called the function, yeah.
So if you were to call the guess function incorrectly, it would add another f to it, but it wouldn't subtract 2.
Yeah, exactly.
So it would just build up.
Yeah. So if you keep guessing incorrectly, it would just keep transferring 1 ETH from the user. But if you try to call this function without 1 ETH in the transaction value field, it would just revert on this require statement because the assertion wouldn't hold.
Right. And it gives you back 2 because you paid 1.
Yeah.
And then it gives you back that 1 and another 1.
Yeah.
Okay.
That's just like what it's sort of coded to do here, transferring 2 ETH. Yeah. Does that make sense to everyone? Cool. So, yeah. So one that's a bit more challenging, I guess like, so this is from the same website. You do the same like deployment. And then, yeah, so then this is the contract now. So I'll just quickly run through it. So instead of an answer, we have a bytes 32 object, so a 32 byte variable called answer hash, which is just a hexadecimal byte value. And it's the exact same for the rest of it. When you deploy, you have to give it 1 ETH. Is complete turns true when the balance is 0. Now guess takes an 8-bit integer again, but it is only true if the hash of that number, Ketchak 256 is like the Ethereum native hashing function. If the hash of that equals the answer hash, so basically it's essentially like asking for like the pre-image of this hash. If anyone like knows much about like hashing functions, I guess like that's an important question. Does everyone here roughly sort of know what like a hashing function does? Anyone wants me to explain it, just let me know, and then I can. But yeah, so like if anyone has any sort of questions about that, let me know. But otherwise, I'll give you guys a minute to think of a potential solution.
So what would be the benefit of storing it as a hash? Because would this code be public code? Is that why you'd want to store it as a hash?
Yeah, well I guess like that's sort of pretty much what like a commit reveal scheme is, right? Where you like commit a hash of some data, to some public ledger or something, and then at some point in the future you reveal it by saying like what the pre-image of that hash was. In the case of like if you want to like prove that you did something in the past without revealing what that thing was or something. Yeah.
Obviously, it's not impossible because it's a challenge.
Mm-hmm.
But can you explain to me why it's not impossible?
Well,
isn't the point of hash supposed to be like you can't get from the answers to the input?
Yeah. I don't know if I can explain it without giving away the answer.
Okay.
I'll give you like a little bit more to think about it. You kind of have to think beyond like just like how can I break a hashing function, I guess. But
Can you just brute force it? Because it's only if n is correct, it's unsigned integer.
Oh yeah.
A bits, so there's 2 power of 8,
Yeah.
which is 256.
256.
Yep.
But brute forcing it also cost. Does it cost?
Yeah. So if you
so it costs you 250.
yeah, so if you just call guess 255 times or whatever, it'll cost you 255 ETH if you call guess that many times.
But then you could get it all back, right?
No, because it's hard coded here to only transfer you 2 ETH when you win. So you can essentially only guess once, or like however much you're willing to pay to win.
But after you know what n is, you can just keep going to get what you want.
Yeah, can you do that?
Can you say that again?
So assume you have 255 ETH. So you have all the possibilities, so you will know which n go by. Give that hash and then you use it.
But you won't get all your ETH back though. If you've guessed 255 times, you'll only ever get back 2 ETH.
Right.
I think you're saying you just guess the correct answer until you.
Actually, yeah, no, that would.
Unless there's a mechanism to change.
No, that's actually correct. Yeah, that would work perfectly well. Actually, sorry, I completely forgot that you can keep calling it after the thing has been called once, after it's been solved once. Yeah, you can definitely do that. I guess like the limiting factor there is gas. But like this challenge is on a test net, so that doesn't really that's not really relevant. So yeah, that's actually definitely a way you can solve it. Say that again, sorry. Sorry. Yeah, so that's definitely one way that you can do it, but it's not like the intended way, I guess, or like the best way to do it. If anyone like has any ideas for.
Is it going to be some? This isn't an answer, but is it going to be something to do with the fact that the guess is like 8-bit and the hash is 32, and then you be some padding in there somewhere, and you might be able to work out some way to narrow down what the hash might be, or to do with the fact when you talked about the first chunk of the hash being the important part, or something like that.
So what we were talking about there was like the function signature, which is sort of irrelevant to this challenge. To answer your question more directly, in terms of like, can you somehow like parse data off that hash and use it to somehow try to reverse engineer the pre-image? I don't think that's possible. Just like
you'd hope it isn't.
Say that again.
You'd hope that it wasn't possible.
I don't know what you just said.
I said you would hope that it isn't possible.
Oh yeah, no, definitely. But like, yeah, because there is only 255 possible pre-images that we can get. Like, yeah, there's still like no way to like determine what those are instead other than just brute forcing. But like, yeah. So were you going to say something? Sorry?
You can only work with these functions, right? You couldn't do like an injection to like make a new function that you can then use.
Not in this case, no. You can only call these functions. But I guess like I'll pose.
Is answer hash like a protected data type? Can you just change it?
Say that again.
Is answer hash protected? Like, can you change it?
No, you can't change it. Well, you theoretically like you could if there was code that explicitly like did that, but in this case here, there's no code that changes that, so you can't change it.
Could you access the answer hash somehow and then run your own 256 hash just locally to crack it and then pull the answer in?
Yeah, that's exactly how you solve it. Yeah. So I guess this is like an important like lesson in that like a lot of the stuff, like a lot of the computation that you can do on chain, like a lot of the time it's just better to like delegate that to some off-chain entity and just enforce that it's like done correctly on chain sort of thing. So the solution to this is actually, this is a JavaScript snippet, but you can see here the goal hash is db81, that's this one up here, the contract address here, and then we literally just iterate through all of the numbers within 8-bit integers, within the range for 8-bit integers. And then we just call this getChack function, which exists in a library that you can get in JavaScript until it equals the goal hash. And then that's your pre-image. So exactly what you said, you just run it locally or off-chain, as we say, and until you get it. And then you call the guess secret contracts.guess function. And I guess here's a cool little thing. You can see like that's the variable that we pass, and this is it setting the value here to 1 ether. But yeah, so that's the solution to that one. Does anyone have any questions about this? It's a little bit more difficult than the first one, but then the third one is another step up.
So they should have made the answer hash a private variable, or kept the hash function they were using hidden then, probably.
So if you make it a private variable, that data is still stored on chain and is still accessible.
Yeah.
The only thing is it's not like, yeah,
So
there's no
accessible, you mean viewable, or actually accessible?
accessible in the sense that you can like get that data, so viewable, but not necessarily accessible in a like a mutable fashion. Like you can't mutate it. What private like stops you from doing is like, I mean, it doesn't really stop anything other than just being able to easily access it.
Yeah. It doesn't work in this context where the source code is readable.
Yeah, like all you need to do to access that variable, even if it was private, is access a certain storage offset in that contract, which would give you the data stored in that part of the contract, even if it is private. But yeah, like the way to solve it is make this n a 256-bit integer, and then like choose the hash based on anything within that range.
Or even like a string.
A way you could make this secure is have, when you create the contract, it specifies the hash as the input to the constructor, and then only the owner sets the value, and it's private. So it's nowhere in the source code, and only accessible by a person.
You can still access it though.
No, if the read function is owner only the owner can read it back.
Yeah, but you can still access, like you can't call like there's no function designated to read that variable, but you can still access that part of the contract storage. Like it's always, being able to access any offset in contract storage is always possible, like regardless of if it's specified as public or private. But yeah.
I guess it's more obfuscation than anything else.
You just have to go into like the binary memory and just
pretty much. Yeah. So yeah, any other questions? Cool. So then this one's a bit more of a challenge. So this one involves 2 smart contracts. So we have this one here that's called setup. So this one actually, it's not from Capture the Ether. This is from the 2021 Paradigm CTF, which is one of the like bigger sort of crypto CTFs that they do. So this one is called setup. It stores this this baby sandbox contract, which is imported here. So it's another smart contract that it's imported. It stores some instance of this contract as a storage variable. In the constructor here, I guess this is like different syntax to this one here. The constructor is called the contract name, but that's because it's an older version of Solidity, but this is a later version, 0.7. The constructor, it sets this sandbox as a new baby sandbox contract, which is just deploying it basically. And we'll look at that contract in a second. And the isSolved function is what's used to determine if the problem has been solved. And what this does is basically it calls an opcode in assembly, which more or less makes sure that the bytecode at this address, the sandbox address, is equal to 0. So if the size is equal to 0, then it returns true. And the only way that that can happen is if like nobody has ever deployed to that address, which is not the case here because we deploy it to whatever address and we store it here. Or if the contract calls self-destruct, which is another opcode which just deletes all the bytecode at that address, at its own address, I should say. So then baby sandbox is the contract that it's deploying. Can we zoom in on this? No.
Yeah, try making it as big as possible.
Yeah. Can I zoom in like through here? That doesn't really help too much. But didn't really think of this one through too much. Basically, okay. So we have a contract. It doesn't have a constructor. It just has this one function called run. This might take like a long time to sort of run through, but I might just sort of like give a lot of hints here to explain this one. But So it's got this one function called run. It goes all the way through to the bottom here, and it's just one big block of assembly. So if we look at the assembly, I hope this is like big enough to read. Should be. Basically, if the caller equals this address, so caller is like who's calling the function, address is the address of this contract, we enter this branch. If not, then we keep going. I'll look at that branch later. This is just a check to make sure that we have enough gas left in this function. And then it loads all of the call data, which is like the data from the transaction. It loads it into memory. And then it calls static call, which basically it gets all that stuff that's in memory, and then it uses that as the data to make a function call to this this contract. So it calls address, which is its own address, using all of the memory from offset 0 that it just copied into memory. And basically, if it returns 0, then it reverts. And static call is basically like you make a function call and you only succeed if no state changed. So if any state changed, then you revert or you return non-zero. But if it didn't, then you keep going. So then if it keeps going, you call call instead of static call, which allows you to make a state change, and then just basically return. So then that's that. And then this one up here, if it's calling itself, if run gets called itself, it calls, it enters this branch here, which calls delegate call, which is another call function, which basically it makes a function call to a certain like address, but it only executes the logic in that address, but it keeps its own storage, like context. So it'll execute a function, but any state change that happens in that function will happen to itself, like to this very contract that's calling it. So basically, if I go back into the presentation, is this supposed to be funny? Seems like it.
Maybe just refresh the page.
So this is definitely like an example of like a real CTF challenge. Like the first two were sort of like, I guess, very like contrived and like beginner friendly, but this one was in an actual CTF that like people were competing in.
If that doesn't work, I have a downloaded copy of this.
Oh, okay.
Downloads folder.
Yeah, it's just going a bit slower.
Yeah, let's just go to downloads and actually see what's happening.
I think it'll, yeah. So yeah, basically it's a bit of a like a sort of hectic function, but all that's really happening is like it just, you call it with a certain address here, so there'll be a certain smart contract at this address, and then it executes this code down here, call data, copy, executes the code. If it's any code that changes the state, it reverts. If it's not code that changes the state, it basically will call run on itself. It'll enter this branch here, and then it'll try to execute the code, but with its own storage instead of whatever the address, like the smart contract that it passed in storage. So like it's a bit hectic, but I guess like, I don't know, like what else do you reckon I should explain?
I think it's good. If you want bigger steps, that's on the next slide.
Yeah, yeah. So this is like the first half of the function, and this is the second half. What were you going to say? I'll pretty much just explain it. So I guess like, does anyone have any like vague ideas for how you could approach this? Like, as I said, this is like an actual challenge. Oh,
Would it be something like you call it with some queries that has some sort of toggle? The first time it runs through, it doesn't do much, but that toggle is then set so that when it goes from the static call, it's okay that for the regular call, your query itself is changed so that when it allows it to then run, it triggers something else that had been hidden previously.
Yeah, that's actually like at a high level pretty much exactly what you do. So like I guess I'll reword it in like a little way. How about you have like some code that like when executed inside a static call context where it's not allowed to change any state, it's somehow like able to like figure that out in a way where it attempts to change the state, realizes, oh, this is gonna like revert if I do this. And if it doesn't revert, then it's like, oh, I know that I'm not in a static call context, so I can do this self-destruct. Is like, that's pretty much like what you were saying. Would
yeah,
you say?
basically like, yeah, where I said a toggle, it's obviously not very sophisticated, but you know, like some value that it can test
Yeah.
which part it's in and then change accordingly. Like, I mean, I don't know if you could knowingly condition on something, or if you would just say, let's guess that there's one check for it, so when it flips to true or flip, you know, to the other thing, you know, we'll have a crack at that, and if not, maybe it's more sophisticated, but that might be something you could attempt on a first sort of go if you didn't have full knowledge, maybe.
Yeah, no, definitely. Like that's pretty much the right approach to take. The way that you would do that essentially is you have to write a smart contract. Well, I guess like I'll sort of like reiterate what he said, which is basically like you have some sort of code that somehow toggles when you have a like a static call context, so that it doesn't try to change the state and therefore doesn't revert. And then it sort of like somehow toggles in a context where it is allowed to change the state and then calls the self-destruct to get this delegate call to like destruct itself basically. And that's like pretty much the right approach. How you do that is you have to write a smart contract that you will pass in as this address here. And then if we sort of follow that code variable down the function, we'll see it's not going to enter this branch here when you first call it, because the caller isn't this contract's address. It'll be some other person calling it. The call data is just this code here. So we copy that into memory. It calls static call with whatever like that smart contract code is. And then if like that code variable, like if that function does make the state change, it will revert. If it doesn't, it won't revert. And then it calls call on itself with that code variable as it's copied into memory as the parameter again, and then it calls itself, it enters this branch, and now code is here, so it'll call delegate call with that function like in that code basically, and then hopefully it'll not revert and the transaction will succeed, and then it'll self-destruct and then the problem will be solved. So basically like, the way that you do that, the actual like proof of concept to solve this problem is you have this smart contract here, and all this does is you have this contract here which is exploit, which actually like executes the exploit. So you have the you call run, which is like this run function here on the sandbox, and you pass it in a new child contract. Child is this contract up here, and all that does is it has a fallback function, which is just like the default function that's called when like nothing else can be called that satisfies it. And now what it does is it tries to call self.check, and that's like a classic try catch block where it tries, and if it reverts, it catches it. So it tries to call self.check. If it succeeds, then it like does the self-destruct. However, if it doesn't succeed, it just does nothing. So self.check actually like tries to call self-destruct, and if it fails, it doesn't actually like do it. It just catches it. But if it doesn't fail, it will like enter this here and call the self-destruct. So in the case of like static call here being called, the self.check will revert, and then it'll go into the catch block here and do nothing. But then when it wraps around again and goes into this delegate call, the code will call self-destruct and not revert, so that then it'll actually self-destruct. And the thing about delegate call is it's called with this calling contract's storage. So when it calls self-destruct, it actually destructs that contract, this contract that's making that delegate call. So that's basically like how you solve it. Do you sort of like get what's going on there?
Yeah, yeah, I get that. Like I wasn't sure initially like the details, but it makes sense that if you want to mess with a contract, that you need to make a contract interact with it. Is the vehicle to load that try catch and
Yeah, so in this case here, the try catch is like the toggle, where like if it succeeds, it'll actually do it. If it doesn't succeed, that's its way of figuring out I'm in a static call, so I can't actually do this, so I'll just do nothing.
Because I'd wondered, I mean, obviously it wouldn't be the case, but you might otherwise have the case that you could maybe see if someone had tested that or made a call, and if they had, I guess it depends on whether you want to allow people to make certain types of calls and you can't differentiate between them. But you know, if you'd seen that it tried to potentially change state by making a call, if there was some way of bumping it out or rejecting it, rather than just letting it happily catch it and then try it again next time, you know, it's a bit.
So basically, like introspectively, like looking at this like static call and what it actually attempts to do. I don't know if like without changing like too much of this code, if you'd be able to do that.
That's what I was curious about. How would you know that you're like in a static call versus a delegate call environment?
Like as in from the context of this child contract.
Yeah, how does the external child contract know?
Yeah, so that's exactly why you have this try statement here. So it'll try to self-destruct, and because self-destruct is obviously a state changing function, it'll revert. Well, it'll revert because static call won't allow it to change any state. So then when that static call like gets called, anything inside it that tries to change state won't be allowed. It'll revert. So in this case here,
so you detect the revert then basically.
Yeah. You're catching the error in a classic like context, in a classic sort of way that you might see in other programming languages. Yeah.
I was thinking you could also like do a 1-2 potentially, right?
Yeah, like have a counter.
Yeah, have a counter as being run before or never been run before, and then it runs the first time in one way, and then the next time it runs a different way.
Yeah, I like when I first solved this was the way that I sort of thought of it, like this solution here. But like I don't know why, like I thought like, and this is the sample solution as well. But it seems to me like a counter would almost be like a much like easier solution.
Yeah.
And I don't know why like everyone like who solved this seems to have like all like agreed that this is the better way to solve it. But like that's definitely, I'm pretty sure, like quite a valid way to solve it. Oh, actually no.
You wouldn't be able to. The external smart contract would need storage, right?
Yeah.
You need to store that.
Sorry, I was wrong. You would not be able to do that because the static call would revert when you tried to change the counter, because that's changing state.
That would revert your external smart contract.
Yeah.
Yes.
So you can't do that.
And you could detect the revert by having a counter like that, potentially.
Yeah, but then you would still have to like update that counter inside that static call.
But is that because you didn't explain exactly how you would detect the revert per se? Like what's the mechanism by which it detects whether it's been reverted or not?
Well, that's the try catch in the context that like the try, if whatever executes here reverts, the whole transaction won't revert. It'll just enter the catch statement here.
Right. That's just the definition of try catch in this environment. Okay.
Yeah. I could have explained that better, but that's how that works. And then another thing is like if you try to change the counter, when the delegate call gets called, you wouldn't be able to access that counter anymore because you would be in the storage
the old
context.
copy.
Yeah, of the thing that called it. Yeah.
Right.
So yeah, I guess like that's why.
That would break it.
Yeah, yeah. So yeah. Also, I forgot to hand out the shirts to the correct guesses. But we can hand out. We've got heaps anyway. So yeah. Yeah. Do you have any more like questions about this? Well, I guess you were asking like how would you like, is there a way that the exploited contract would be able to tell that it's like?
I don't know if you would need to treat something like blow up the whole thing as something that's dealt with separately rather than allowing it to just flow through with your regular calls, because you presumably want it to take a bunch of regular calls and not be too fancy, because the more sophisticated it is, the more cost it might be potentially. So that's why I was saying you might want to ring fence the are we going to let it blow stuff up thing and maybe treat that as a special case. But
yeah, well this is definitely like a pretty contrived sort of example. You could like obviously like secure it and make it non-exploitable, but that would require like essentially like changing the entire smart contract. Like there are ways to safely use like delegate call, but it wouldn't have this format anymore. Like you would essentially have like a completely different smart contract.
If you were to, and you knew it had arrived somehow, send your query to it, how would the whole thing be resolved in that particular block? Or might it be staggered over blockchain? And so I'm thinking that if you can have a counter, but maybe you know the behavior of your program and how many times it might have tried in a given number of times. I mean, if it goes completely to resolution, this block, then it's a kind of a black box, but otherwise you could monitor something else. Maybe you've got another little contract somewhere and you use that as your counter, so that every time you try, you increment your free or almost free contract elsewhere and use that as a proxy counter for how many times it goes. But then I don't know, if this just goes to resolution, then you won't really necessarily know if you have to try once, twice, 10 times. Or
yeah, it's an interesting idea, but I don't think it would work because, as you were saying, it goes to resolution. So every transaction's atomic in the sense that it either completely goes through or it doesn't. So when you try to call the static call, and then if it succeeds or if it fails or whatever, you're not going to be able to get to that delegate call like in another transaction unless you go through that static call again. So you can't like wait until the static call's over and then the transaction ends and then you update some other contract and then you like enter in again and continue from there, if that makes sense.
Yeah. I wonder if maybe you could have something that just doesn't seem to do much on the surface, but each time it tries, it just does a cheap transaction somewhere else, and so that it does resolve fully, that you just increment or decrement something. But I don't know, that's kind of blue sky thinking of me.
Yeah, I'm not fully sure like what you're suggesting, but like I guess the difficult problem here is like it has to go through from start to finish. Otherwise nothing will go through, if that makes sense. So like unfortunately you can't really like block it halfway through, like block it at any point, like and like keep the state updated, because essentially like each time you call this run function it'll start from scratch, if that makes sense.
Yeah, I suppose like if you knew that roughly it was going to try the same sort of thing, but there was a bit more to it, and so it would be good to know how many times it tried to run it to test out if you were being sneaky, and so you might just run something that doesn't appear that malicious on the surface, and it just executes a little contract or executes something that gives you information elsewhere to say that we successfully queried on something, some number of attempts or something, I guess. You know, in a more closed way rather than so that your query is resolved and your increment elsewhere of something you're trying to monitor is also like all fully resolved. So.
But your second attempt, where you get inside, the second attempt has to happen within the same blockchain transaction.
Yeah.
So I guess you'd have to like that code would have to be running on the blockchain, and then mid transaction you would have to signal to some outside party, like putting money into some account, and then you could read that, go down a bit more and read that you've put money into that account, and then come back. But that wouldn't be possible within the one block being executed.
Yeah. It kind of.
It's just like all containerized, and then it happens, and you see the result.
Yeah, like
Right, okay.
containerization is maybe a good mental model here in the sense that, like, there's no way to sort of time it, and like, even if you accept that the transaction has to go through all the way, you can't like time it such that some other contract execution will happen midway through your transaction, if that makes sense. So
yeah,
like,
that all makes sense. Yeah, I was thinking like a containerized thing, but it's a bit loosely formulated at the minute.
yeah,
When I've drained some big exchange somewhere, I'll let you know.
yeah,
You'll hear about it.
yeah. Let us know.
Leave it on Twitter.
Yeah. So yeah, any other questions about that? Sort of went on for a bit. Cool. Alright, so I guess like how do you get better at this sort of thing? The guys left who asked this question, but so like obviously like I guess with like maths or whatever, it's always good to like try to solve things without like looking at the solution. That sort of goes without saying. Yeah, you see people do like write-ups for CTF challenges a lot, like outside of crypto, and like I think that's probably like a pretty good learning experience. Code Arena is the thing I was talking about earlier. That's like a public like thing where real projects will put up money to like have their stuff audited, and then you submit findings and you can make money off it. Some of the best auditors make like a pretty massive amount of money off doing this. Like I think one guy made like $1 million in like 10 months or something like that. But yeah. So, and then reading about real exploits is often like pretty good as well. And yeah, this is like an upcoming CTF if you want to like get involved. ctf.paradigm.xyz, run by Paradigm, which is like a crypto research sort of company. Starts 20th of August, 48 hours. There's heaps of different there's not just like smart contract challenges, there's also like cryptography challenges as well, just like pure cryptography rather than like cryptocurrency challenges. And yeah, like you can sign up and just participate on your own or like with the team, etc. Yeah, that's the end. Any questions about anything? Cool. And I also should tell you guys to join our Discord. Mycelium.xyz is our website. It'll be like on there. If you want to join, follow us on Twitter. I don't know what our Twitter handle is.
Mycelium_ETH.
Okay, Mycelium_ETH. And yeah, so yeah, hit us up on Discord and Twitter.
Woo.
Woo. Thank you, everybody.
Come grab a shirt. If you want one. So there's medium, extra large, and 2XL. But they're like small. They're small.
Thank you very much.
Yeah, the mediums.
Taboo to wear if you don't work there.
Although it's black on dark green, so
It's not very nice. I like how it's green, actually.
Yeah, they were like, I was about to
these are the new versions.
Yeah, true. You literally can't. Yeah.
yeah. I think it was like actually not ordered that way. Like the manufacturer fucked it up. I think it was a refund on them or something.
Is that why these are the 3 ones?
I don't know actually. That wasn't my decision which show to do it. So I'm not gonna answer. Oh, no, stickers. Yeah, stickers.
Free stuff.
This is the new version.
Oh, no, they're small.
Oh,
Yeah. Yeah, nice to meet you. I'm Ben. Cool. Thanks. I'm glad you enjoyed it. Nice. Are you gonna like get deeper into smart contract development?
Honestly, after this, like, completely.
Yeah. Like business, like what's VA? Yeah, I reckon there's probably like a decent amount of like sort of jobs in that space. Not like fully sure, like I don't really know too much about it.
That's what you're twice today. Sorry.
Yeah. There's also like I mean I think like business sort of stuff is reasonably like high demand as well.
He tutored someone, I tutored.
Not too sure.
I tutored him, he tutored another kid in the course, and another kid tutored another kid in the course. I had like two generations who I tutored at the same time.
Into the USDC. Did you see the recent announcement of like Reddit initiative? Yeah, they're gonna like put their community thing up scoring yeah, we're actually if you check like Twitter and shit, we're actually migrating to all the it's just Mycelium. The migration contract has actually already been deployed. We just haven't been but yeah, it'll be like a one-to-one migration. So if you had any trades, like there's no like time, like you'll be able to do a contract with all those disks there, but yeah, you'll need to like migrate your tracer to Mycelium, and like we're like rebranding like the whole product basically.
And I saw the very original Mycelium operating like service and flows to transfer, but this was
so like technically like the tracer DAO is like deployed anonymously and like it started as a DAO like that, and then it like contracted Mycelium through the DAO. But like we always be like the main like contributor to the DAO and stuff.
So now it's just like the full
the proposal passed, so like technically like it was definitely like an interesting period like that first bit, but like we've been like here's the main not only contributors to the DAO but the main like facilitator of basically all of the DAO stuff. And we'll be like doing like essentially like and all of our like previous stuff with like the chains and stuff, that's all coming under the Mycelium like umbrella as well. So it's so like that'll be like instead of like being a separate project, that'll be like the infrastructure team for Mycelium, and like the tracer like people working on tracer will be part of like the financial products team for Mycelium. So instead of being like subsidiary like products, they're like just like part of Mycelium, and then like Mycelium, it's like it's so much better in my opinion because it's basically like more coherent and more like consolidated within the company. Like we're all like working on like the same thing, even if they're on different teams. We're all so like short term, that's one of our main focuses like week and like migrating liquidity. But also like we're launching like a Perpetual Tools next week I think, which is like it'll like start as basically like a genomics fork, so we've got like our own like mechanism that we're gonna like iterate on top of that sort of thing. So it's like pretty much like if I like when I mentioned I wanted to like run an actual CTF thing here, and I was too confused because I was working pretty much. And, like that's like public information. I think if you don't like Twitter and stuff. But yeah, so like we're doing that and like more like infrastructure stuff, and like we'll be like doing a bunch of other stuff as well. But yeah, short term is that sort of stuff. And then we have, I guess like I don't know like how much like we'll have to like tell people like other like products and stuff as well. New financial products.